Hi everybody, this is Matt Morgan. In this lesson we're going to talk about parts per million and parts per billion from Wiley section 12-3.1. We'll go over some definitions of parts per million, parts per billion, how to convert to and from those values, and we'll work a homework problem, Wiley 12-020. So parts per million is one way to quantify very small amounts of solutes that you have in a solution, or small portions of a mixture. One use of parts per million is to define the amounts of trace gases that are found in the air. Helium is present in an amount of about 0.0005%. All of those zeros become very cumbersome. They get in the way when you're dealing with these very small values. So parts per million is a way to express these in a much simpler manner. Percent is the same as saying parts per hundred. Parts per million is 10,000 times smaller than 1%. The amount of helium in the air is 5 parts per million, which means if we have 1 million air molecules, 5 of those are helium. That's a really small amount, but 5 parts per million is a lot easier to discuss than 0.0005%. Great example of parts per million that you probably hear every day is global climate change, the effects of carbon dioxide, increasing carbon dioxide levels, their effects on the environment. An 80 part per million rise seems alarming, and it is. It's a continued increase. But if they said 0.008%, would that be as dramatic? 400 parts per million, the amount of carbon dioxide, is 0.04%. An increasing amount, but not a large amount by itself. So 1 part per million, very small. Our measuring capability has improved beyond that, however, and we can measure values of some solutes in levels at parts per billion. Imagine 1 gram in 1 billion grams of solution. That's a really small amount. So how do we calculate, how do we find parts per million and parts per billion? A lot of times we'll start with percent by mass, something we're familiar with, and we'll convert. Example 12-2 in Wiley shows us how to use this method. Example 12-2 on page 406 gives us a great method for solving parts per million and parts per billion problems. The phrase you want to get out of that example is find the mass of solute per gram of solution, multiply 10 by 10 to the 6th for parts per million, 10 to the 9th for parts per billion. And when they mean mass of solute, they mean grams of solute. Here are those formulas. Okay, parts per million, mass of solute over mass of solution, 10 to the 6th. Parts per million, mass of the solute divided by mass of solution times 10 to the 9th. Now mass on the top and the bottom have to have the same units. It can be grams over grams, kilograms over kilograms, milligrams over milligrams, but make sure they are the same for this unit to work. Let's look at a homework problem, Wiley 12-020. This problem says a high concentration of mercury in fish is 0.6 parts per million. What mass of mercury is present in each kilogram of fish? We're going to use the parts per million formula from the previous slide and pay attention to units. We should always do that. Okay, there's our problem. Here's our formula. Now one thing we're going to do, the answer block in the Wiley problem asks for grams. So rather than plug in 1 kilogram, we're going to put in 1,000 grams for our mass of solution. zero point 0.6 parts per million, 1,000 grams of fish times 10 to the 6th. We have one equation, one unknown. We're just going to use some algebra and solve for our mass of solute. We're going to multiply by 1,000, divide by 1 times 10 to the 6th. I'll give you a minute or so to do that. You can also pause the video. I'm going to have an answer down, but you need to check it. Don't trust me. I get 0.0006 grams, or 6 times 10 to the 4th. If you put this answer in Wiley, you can say 6e minus 4. The second part of the problem asks for what is this concentration in parts per billion, referring to the 0.6 parts per million. Couple of ways to work this problem. If you can visualize, if you can see that a parts per billion is 1,000 times smaller than a parts per million, you'll know to multiply 0.6 by 1,000. There's a lot more of the small things in the bigger thing. However, if your brain doesn't work that way, that's all right. You can set this up and work it mathematically. We will take our 0.0006 grams over 1,000 grams from the first part, and we'll plug it into the parts per billion formula. Remember that. Mass of solute over mass of solution times 10 to the 9th. Put our values in. We don't even have to do any algebra. We'll just do the math. 0.0006 divided by 1,000 times 10 to the 9th. Let you work it out. And I get 600 parts per billion. Now the given information had one significant figure. We can say 6 times 10 to the 2nd, or 6e2 for Wiley. So we talked about parts per million and parts per billion. We went over formulas for how to calculate these values, and we worked a homework problem. If you have any questions about these concepts or any other chemistry concepts, please contact your course mentor. Here is our The main job of your course mentors is to enable your success in these courses. You can email us at the group inbox at chemistry@wgu.edu, or you will find contact information for your individual course mentor in your course of study.